So far we've looked at what happens with exponents when we multiply or divide powers, but so far we've looked at positive exponents. Now we're going to take a look at zero and negative exponents. So first of all, for zero exponents, we're going to say that by definition, any non-zero number a raised to the zero power is simply equal to 1, and this is something you pretty much just have to memorize for now. Okay, now what about negative exponents? Well, a to the negative n is going to be the reciprocal of a to the n power. So in other words, if we have a to the negative n power, we're going to say this is the same thing as 1 over a to the positive n power. Then likewise, a to the n is the reciprocal of a to the negative n. So in other words, we can say a to the n, the positive n, is equal to 1 over a to the negative n. And what you're going to find here is that you can move powers back and forth between numerator and denominator. You simply have to change the sign of the exponent. So if it's negative in the numerator, it becomes positive in the denominator, and then just the opposite. If it's positive in the numerator, it becomes negative in the denominator. So let's look at some examples and see what we're looking for here. Okay, in the first few problems, the directions tell us to evaluate the expression. So we want one final number here. So 3 to the negative third means we're going to look at 1 over 3 to the positive third power, which is going to be 1 over 27. If you take 3 times 3, in other words 3 squared, that's 9, times 3 again will give us 27, and there's our answer. In number 2, we have negative 2 to the negative fourth power. We can rewrite that as 1 over negative 2 to the positive fourth power. Now remember, when you have a negative inside parentheses and you raise that to an even power, this is going to end up being positive. And we end up with 1 over 16. So negative 2 times negative 2 is positive 4, times negative 2 again is negative 8, times negative 2 yet again will give us a positive 16. Okay, number 3, we have 1 divided by 3 to the negative 2 power. So this is 1 over 3 to the negative 2 power. We can make that a positive exponent by bringing it up into the numerator. So this is going to be equal to 3 to the positive 2 power, or in other words 3 squared, which is 9. Okay, number 4, we start getting a new set of directions here, and the instructions tell us to simplify the expression and write your answer using only positive exponents. So here we have 4x to the 6th times 2x to the 0 power. Well, we can look at our coefficients first. So we have 4 times 2, and then look at, we're multiplying x times x, so we can add the exponents, 6 plus 0. So this will give us 4 times 2 is 8, and x to the 6 plus 0 is x to the 6. Another way that you could look at this is x to the 0 is the same thing as 1, 2 times 1 is 2, and then 2 times 4x to the 6th is 8x to the 6th. Okay, number 5, we have negative 4y to the negative 9th times 3y squared, so we can take negative 4 times 3 for our coefficient, and then for y we're going to add the exponents since we're multiplying, so we take negative 9 plus 2. So for our coefficient we're going to have negative 12, and then y to the negative 7. Negative 9 plus 2 is negative 7. Now we have to rewrite this using only positive exponents. So we can write this as the negative 12 stays in the numerator because that exponent of negative 7 only applies to y, not to the coefficient. So in the denominator we'll have y to the positive 7th power. And if you want, you could rewrite that as negative 12 over y to the 7th. So either one of these is okay, negative in the numerator or negative out front. Okay, number 6. We have 4q to the negative third times negative 2q to the 0, all raised to the third power. So I'm going to deal with this expression in parentheses first, being raised to the third power. So we can say this is 4q to the negative 3. Now, q to the 0 is simply 1, so we can write that as negative 2 times 1, all raised to the third power. Or in other words, 4q to the negative third times, and then of course negative 2 times 1 is just negative 2. Negative 2 to the third power is negative 8. Okay, negative 2 times negative 2 is a positive 4, times a negative 2 is negative 8. So now we have 4 times negative 8 is negative 32, and we have q to the negative 3 power. Now of course, that exponent being negative, we need to pull the q down into the denominator. So we can write this as negative 32 over q to the positive 3 power, or if you want, you can pull that negative sign out front, and we'll have 32 over q cubed. Right, number 7. We have 2xy cubed all to the negative 2 power times negative 8x to the 7th, y to the 9th, to the 0th power. Now the nice thing about this one is no matter how complicated the term inside the parentheses is, it's going to be raised to the 0th power, which means this is simply 1. So this is 2xy cubed to the negative 2 power times 1. Or in other words, just 2xy cubed to the negative 2nd power. We can rewrite that as 1 over 2xy cubed. And because everything inside the parentheses is raised to a negative power, we pull everything in parentheses into the denominator. So now this is going to be to the positive 2 power. So this is equal to 1 over, and now we have to apply that exponent of 2 to each part of this term. So this is going to be 2 squared, and then x to the 1 times 2 power, we have the power of powers here, times y to the 3 times 2 power, which gives us 1 over 4x squared y to the 6th. Okay, so we have all positive exponents there. All right, number 8. We have negative x to the 4th over negative 4 x to the negative 3. Well, first of all, we know that a negative divided by a negative is positive, so we can simply rewrite this as x to the 4th over 4x to the negative 3. And now we can see that we have x in both numerator and denominator, so we can go ahead and subtract the exponent that's in the denominator from the exponent in the numerator, and we'll keep the 4 down here. Remember that exponent only applies to the x, not to the 4. And this will give us 4 minus negative 3 is a positive 7. So we have x to the 7th over 4. Okay, number 9, a little bit of a tricky problem here. Let's see how this works out. Let's go ahead and deal with the numerator first and simplify the denominator as well. So this is going to be equal to a negative. We have 2 times negative 2, dealing with the coefficients, and then m, we can add our exponents here, so negative 2 plus 0, and then n cubed. Notice that this is the only place in the numerator where n shows up, so we still have n cubed, and this is all over, now simplify inside the parentheses, 2 times negative 1 is a negative 2, m to the negative 2 plus 4, and n to the negative 2 plus negative 4. Okay, now all of this is in parentheses raised to the negative 4th power. Okay, so this is equal to We have a negative sign out front. This is negative 4 m to the negative 2 n cubed. And then in the denominator, we have negative 2 m to the positive 2, so m squared, n to the negative 6. And all of that is raised to the negative 4th power. Hey, now we know that this is a negative exponent, so we can bring this entire expression up into the numerator. So this is equal to negative, and then we have negative 4 m to the negative 2 n cubed times negative 2 m squared n to the negative 6, all raised to the positive 4th power, and if you want you can write that over 1. Okay, now let's apply this exponent of 4 to this expression inside, or this term inside parentheses. So this is equal to negative, and we have negative 4 m to the negative 2 n cubed. So we have negative 2 to the 4th power, and remember we want that negative 2 inside parentheses. That's going to end up being positive. And then we have m to the 2 times 4 power, n to the negative 6 times 4 power. Okay, so this is looking lovely, isn't it? Alright, so we have, now I'm going to go ahead and take care of this. We have a negative times a negative, so this is going to be a positive 4 m to the negative 2 n cubed times 16. Negative 2 times negative 2 is a positive 4 times negative 2 is negative 8 times negative 2 is a positive 16. And then we have m to the 8th and n to the negative 24. Okay, having fun yet? Oh yeah, this is good. So we have 4 times 16 is equal to 64, and now we can add exponents between the two terms. So we have m to the negative 2 plus 8, which is m to the 6th, and then n to the 3 plus negative 24, which is negative 21. And finally, we can rewrite this. The n has to go into the denominator because it has a negative exponent. The 64 is just our coefficient. That will stay in the numerator, and our m will stay in the numerator because of the positive exponent. So we end up with 64 m to the 6th over n to the positive 21st power. So this is much more compact and nicer to look at than this mess right here. Took us a while to get there, but we made it. And if you can handle this problem, you're in good shape for working with powers. Good luck.